Welcome to this short video showing you how to find maps at the GEUS website. GEUS is a national geological survey of Denmark and Greenland. And on the GEUS website you can access both maps and data. In this video I'll show you how to access these four maps that you see on the screen. It's a map of soil types, it's the level of the pre-quaternary surface, it's the sediment types at the pre-quaternary surface, and it's the top of limestone. You can recognize these maps when we enter the website. It's these four titles that we're looking for on the website. The easiest way to access the GEUS website is simply writing GEUS in a browser. And choose GEUS. And when you enter the GEUS website, you can change the language from Danish to English here. And then we choose Products, Services and Facilities. And choose Data and Maps. And then you can see we get access to a lot of different datas and a lot of different maps, and we will choose Maps of Denmark for this session. And when you enter this part of the website, choose See Maps of Denmark online. Now we have a normal WebGIS window with the map here. We have the different layers or data or maps here, and we have a scale bar. We have possibilities of zooming in and out. We can also write a location and make the map zoom in on that. In this case I'll write Horsens. Here we have Horsens city, and we can move the map a bit so we can see the part of the Horsens area that is interesting for you. First of all, we have the surface geology map of Denmark. Remember, when we looked at these four maps, we need to look at the surface geology map of Denmark 1 to 25,000. And we have two possibilities here. We have the 1 to 200,000. It's not so detailed, but we have a very fine legend here. And if we choose the 1 to 25,000, it's more detailed, but the legend is more difficult to read. My suggestion is to use this map and then copy the legend from the 1 to 200,000 map. When you look at the maps in GEUS, you can make them more or less visible, make the background map shine more or less through. It's called the transparency. So if we have no transparency, we only see the map chosen, and if we make it more transparent, you can actually see the map lying behind the data layer. And here we can see the individual roads. Normally it's a good idea to be able to see some of the background so we can make sure where are we in the area. The surface geology map of Denmark shows the soil types. The brown color represents moraine clay. Moraine clay has been deposited underneath a glacier, so it's pre-consolidated and pretty firm. The only problem is that clay is frost susceptible, so you need to take that into consideration when you plan your road building, if you are placing your road in areas with moraine clay. The red color here represents meltwater sand and gravel. Meltwater sand and gravel is normally fit to build on, and it has the advantage that it is not frost sensible at all. So the thickness of the layer that you put underneath your road can be smaller in areas where we have meltwater sand and gravel. The orange color here represents meltwater clay that has been deposited in an ice dammed lake on the meltwater plain. And then we have the green colors. Green colors represent areas with organic sediments. And remember, organic sediments are not good to build on directly. So you need to take that into consideration when placing your road. That was the surface geology map of Denmark, the soil type map. Let's have a look at the next map that we see on our list. That is Topography of Pre-Quaternary. We find it here. And I will zoom out a bit so we can get an overview of the different items in the map. Again, I will make it more transparent so I can see the map lying behind it. We need to get the legend on. This map here shows us the surface or the level of the surface of the pre-quaternary sediments. Pre-quaternary meaning the time before the quaternary, meaning the time before the ice ages. So if you imagine you take away all the ice age sediments, this would be the surface you were left with. And you can see that here, for example, in the central part of Horsens, this surface is lying pretty deep, maybe more than 250 meters below sea level. And you can also see that there are areas where the pre-quaternary surface lies very high, in this case more than 100 meters above sea level. These levels are always according to sea level. So if we have a minus in front, it's below sea level, and if we don't have a minus, it's above sea level. You can see that the range between 0 meter and 25 meters below sea level is around here. You're supposed to make a map of this pre-quaternary level and comment on it. Do you have areas where the pre-quaternary surface is lying high or lying low? Then the next map that we need to make is the Bedrock Geology of Denmark. This represents the sediment types of the pre-quaternary surface. So again, imagine you took away all the ice age sediments from the area. When we show this map, we see what kind of sediment types is lying at the pre-quaternary surface. I'm zooming out a bit so it's easier to overview. The orange color that we have here, we have Horsens here, is from the time period called Oligocene. The brown from the time period called Eocene, and the dark brown from the time period called Paleocene. The green color here represents the time period called Danian, where we have deposition of limestone. The brown colors representing Eocene and Paleocene tells us that we have plastic clays lying at the surface underneath the ice age sediments. Oligocene means that we have plastic clays, but they become more silty and more sandy towards the top of the Oligocene time period. Again, it could be a good idea to make it more transparent so we can see where we are. We have Horsens here. The black lines represent fault lines, meaning that's actually places where the underground has broken up. Just for example, as the St. Andreas fault line that we have been talking about some lectures ago. It is lines where there has been, for example, one part of the the underground can have been pushed up and the other one has been lowered. So there might be differences in the level of different layers. It's not really important for your project areas because they play no role for projects close to the surface today. Then finally we need to make a map of the top of the limestone. That map is named the top chalk of the Danish area. And we can find this map down here. When we put this on, it becomes grey, and this is simply because we have to zoom out a bit for it to be visible. We have to zoom out a bit more and still a bit more. And now we can see it. It can be difficult to see where Horsens is. Again, we can make this transparent, and you can see Horsens is lying here. Actually, it looks like the top of the limestone is lying deeper in the central part of Horsens, down to approximately 600 meters below sea level. When we move north of Horsens, we can see that the level is not that deep. It's around 400 meters below sea level. These are the maps that I expect you to make in connection with your semester project, and to describe the maps and to describe what are the impacts on your project. For example, if we look at this map of the top of limestone, if it is lying 400 meters below sea level, then we can imagine it plays no big role or has no impact on your project. But if we look at the pre-quaternary map showing us soil types underneath the ice age sediments, we can see that we have plastic clays lying in the brown areas, and we have also clays here that can be classified as plastic clays. They are getting more and more silty, but still we have plastic clays in Oligocene. And if we combine this map with the topography, we can see that it will play a role where the top of the pre-quaternary surface is lying close to terrain, but will not play a role where it is lying very deep, because then, for example, here in the central part of Horsens, there will be more than 200 meters before you reach the pre-quaternary surface. Yes, this ends this small video on how to find these 4 maps on GEUS website.